Hello everyone. In this session, we will see what is a decentralized network, how it is different from a centralized and distributed network, what is a peer-to-peer network, difference between a peer-to-peer and server-based network, and why blockchain is known as a distributed peer-to-peer network. So before starting, let's see what is a centralized network, what is meant by a decentralized network, and finally what is a distributed network. First is a centralized network, which uses a client-server architecture where one or more client nodes are directly connected to a central server. A single server handles most of the processing. Usually the main server is a powerful machine which is connected to less powerful workstations called clients. The user requests are made at the clients, which they submit to the server rather than performing them directly. It can include data storage, applications, and utilities. Such architecture is most common in many organizations. Each client request is processed at the server and the response is sent back. Some of the key advantages of centralized network management are efficiency, consistency, and affordability. In a centralized network, the network administrators are under pressure to keep machines up to date, and having one central server for controlling the whole network takes less IT management time and fewer administrators. Also, the data on a centralized network is required to go through one place, so it's effortless to track and collect data across the web. But there are some disadvantages to centralized networks. First is a single point of failure, which can be a huge risk for any system. If the server goes down or crashes, all the user requests from clients cannot be processed. This results in compromising the availability of the system as the client machines cannot complete all user requests. Another disadvantage of centralized networks is their limited extent of scalability. As all the applications and processing power are supported by a single server, the only way to scale is to add more storage or processing power to that single server. In the long run, such scaling may not be cost-effective. Another disadvantage is for businesses with fluctuating demands. In that case, the server proves to be a bottleneck in processing all requests. With high user requests, it can be challenging for a single server to keep up with processing an influx of concurrent user requests. Now if we talk about a decentralized network, it distributes the workload among several machines, instead of relying on a single central server. The increase in the processing powers of desktop and laptop computers these days can serve requests beyond the needs of most business applications. The extra compute power of the desktops and laptops can be used for enabling distributed processing. There are a lot of advantages to using a decentralized network in place of a conventional centralized one. Decentralized systems are more reliable as there is no single point of failure. Another benefit is high scalability. In order to increase the computational capability of the system, you can simply add more machines. Decentralized systems also offer greater privacy as compared to the centralized ones. All the information passes through a number of different points as compared to a single point in a centralized system, making tracking difficult. However, on the downside, the additional number of machines in a decentralized network calls for more maintenance and potential issues. This adds an additional burden on a company's infrastructure and IT resources. Another type of topology is a distributed network which is expanded over different networks. It provides a single data communication network, which can be managed jointly or separately by each network. A distributed network can also distribute the processing. In a distributed computing architecture, the IT resources of an enterprise are managed in distributed networks. The resources are divided over a number of networks. On top of it, a network management software manages and monitors the core networking processes like data routing, combining and allocating network bandwidth and access control. An architecture with distributed network and processing is used in an application which is hosted and executed from a single machine but is accessed by many remote users. A client-server computing architecture can also be a distributed network. In such a system, the server caters requests from many interconnected remote users accessing the application from different networks. Now, what is a p2p network? A p2p or peer-to-peer network consists of a group of devices that collectively store and share files. In such a network, each participating node is an individual peer. Each node is the same and performs the same tasks. Each node stores a copy of the files. A peer-to-peer network is different from a traditional client-server system as a node can act as both client and server here. A node can act as a client and download files from other nodes. A node can also act as a server and upload files to other nodes. There is no central authority managing and regulating a peer-to-peer system. Each node in this network is equal to another. Files can be freely shared between nodes in the network. Peers can talk to other peers in the network to search and share any data. A node can be a source from which other nodes can download files. This is when it acts as a server. And it can download files from other nodes in the network when it acts as a client. A node can assume both roles at the same time. A p2p network is intrinsically not secure if you look at its design. It was created to cater a small set of nodes in a private network. In case of blockchains, a distributed network is used for the exchange of cryptocurrencies or digital assets. P2p platform sellers and buyers execute trades without any need for intermediaries. Some businesses also maintain a peer-to-peer network connecting the borrowers and lenders. In the 1990s, P2P architecture became popular with the file-sharing programs built using it. Currently, P2P architecture mostly powers the cryptocurrencies network. It is also adopted in distributed computing applications like search engines, online streaming platforms, marketplaces, and interplanetary file systems, also known as IPFS. In practice, with a large user base, such networks tend to provide faster and efficient data transfers. Due to their distributed architecture, P2P networks don't have a single point of failure and thus are less prone to cyberattacks such as denial of service. Peer-to-peer systems are categorized into three main types named as unstructured, structured, and hybrid P2P networks, based on their architecture. In an unstructured P2P network, there is no specific organization of the participating nodes. They can communicate randomly with any other node. Such a system is resilient for several nodes frequently arriving in and departing from the network. Despite being easier to build, these systems require higher memory and CPU usage. Any search query is flooded in the network to maximum number of peers. And if only a small number of nodes have the desired content, the query has to be transmitted a long way. A structured P2P network, on the other hand, is built as per a more organized design. Its architecture provides a precision search for the content that is not available generally. This is made possible by using hash functions which allow faster database lookups. Even if structured networks are more efficient than unstructured networks, they manage to present higher levels of centralization and require higher maintenance and setup costs. A structured network is less robust in case of high churn in the network. Another P2P architecture can be a hybrid of client-server and peer-to-peer model. Such a system can manage connections between peers via a central server. These hybrid models provide an improved overall performance through a significant degree of decentralization and maintaining efficiency as well. So, how server-based systems are different from peer-to-peer networks? In a server-based architecture, the network security and storage are controlled centrally through servers. They manage network tasks such as storing files, authenticating users, running applications such as database and email programs, and also managing printers. Files are easily secured and backed up centrally. Users have one user account for logging onto any computer in the network. This arrangement manages the user's security. Server-based architecture is more complex and costly to administer and set up than peer-to-peer networks, and it often needs the services of a full-time network administrator. This architecture is more suitable in business cases where security and file integrity are more important. Some of the examples of server-based networks are Microsoft Windows 2012 or Windows 2016. These platforms offer centralized network administration, NTFS file system security, and networking which is easy to set up and configure. They also offer file and print sharing, routing and remote access for supporting mobile users. For login, user profiles can be maintained to allow a single user to log on to many computers or to allow multiple users to share one computer. Internet information services can also be established for creating an intranet. On the other hand, a peer-to-peer network was originally meant to serve a small group of users in a private network, for example, a department in a small office. Till now we have discussed decentralized, distributed, and P2P networks. Now, let us see how these are introduced in the blockchain network. Satoshi Nakamoto, the creator of Bitcoin, defined it as a peer-to-peer electronic cash system. It is a digital money which can be transferred among users through a P2P network. The record of transfers in this cash system is managed in a distributed ledger called blockchain. Bitcoin eliminates the need for any central server or intermediaries, allowing Bitcoins to be transferred worldwide. Anyone can participate in the network by setting up a Bitcoin node and processing transactions and blocks. There are no recording transactions and banks processing in the Bitcoin network. Blockchain is a digital ledger that publicly maintains records of all fund transfers. To ensure data accuracy, each node can compare its local blockchain copy with its peers. Full nodes in this network store a copy of the blockchain and keep on updating it with new blocks. They participate in verifying the actual state of blockchain. There are many merits of the p2p architecture of networks in blockchains. It is more secure than traditional client-server-based architectures. As the blockchain is maintained by a large number of participants in the network, it gets highly difficult for a malicious actor to execute a denial of service attack on blockchain, which is otherwise common in many centralized systems. In order to alter data in blockchain, a majority of nodes must come to a consensus on the blockchain state. This makes the blockchain immutable. This gets more and more difficult in bigger networks like Bitcoin and Ethereum. So a distributed p2p network which requires a consensus from the majority of its participants ensures a resistance to malicious activities in a blockchain. But smaller blockchains which are comparatively new are more susceptible to such attacks. In a small network, it becomes easy for a person or a group to control a majority of nodes. The peer-to-peer, distributed network in blockchains also provides resistance to control by a centralized authority. The cryptocurrency wallets can't be drained or frozen by governments like standard bank accounts. Online merchants use cryptocurrency payments to remove the role of any third parties. Despite many advantages, the use of peer-to-peer networks on blockchains has certain limitations. First is the use of massive computational power network-wide. With each transaction, the distributed ledger at each node must be updated to the latest state. This greatly reduces the efficiency provided in a centralized system where data is updated in just one place. This hampers the scalability and adoption of such systems. Scaling solutions are one of the prime research areas in the blockchain space. One more drawback is related to the hard fork events in blockchain. As the implementation of blockchain is open source, nodes are free to copy and alter the code. This led to nodes splitting from the main network and creation of a parallel network. These chains become vulnerable to attacks, like replay attacks, if certain security methods are not embraced accurately. Also, the distributed nature of peer-to-peer networks makes it relatively difficult to regulate and control, not only in the blockchain. As a result, many users and companies have been involved in illegal activities and copyright infringements. That's all for this session. For any query, please visit community.blockchain-council.org, and you can also email us at hello@blockchain-council.org. Thank you.